Hey guys, thought I'd just make a couple of videos to hopefully facilitate your guys' data analysis for your treatise. I'll divide this into a couple of videos, parts looking at regression, parts looking at the differences in the values that you've obtained, so on and so forth. So the first part is trying to test for differences in some of the variables. So say for example, if we're trying to compare the Vo2 Max values of the different tests. We want to try and see, are they comparable in terms of what happens in the lab versus what happens in the field, or are they significantly different? What is the case? Are the critical velocity values the same or too different? Can we compare them? Can we not compare them? And we'll start using that information to construct our regression models. Okay. So in order to test for differences, you have to set up your null and alternative hypotheses. And I know the moment that I mention those two words, your guys' eyes will probably glaze over. But hopefully I'll make it a little bit more clear in terms of what you guys have learned in your stats lectures. So please pay attention. This is really, really important for you guys' interpretation. Okay, so your null hypothesis, in a nutshell, always assumes that everything is the same. There's no difference between two variables or two groups or whatever the case may be. Everything's the same. So whether you're looking at the mean, or you're looking at variance or variation, or you're looking at Vo2 max, or you're looking at two groups, part of what you want to establish is whether they all are the same. So that's what your null hypothesis basically states. Everything's the same. Your alternative hypothesis therefore states that everything is different, or at least not the same. Right? Fairly intuitive. Alright. So there'll be different types of tests that you guys will run in terms of finding, like, if there's a difference or similarity in the mean or variance of Vo2 max or whatever the case may be. Right? But a common factor is that it will spit out a p-value, right? So the p-value simply states what the probability is that your null hypothesis is true. Right? What are the chances that this is true and not due to some random error or some random variation or whatever the case may be? Right? If your p-value is less than 0.05, it means basically the probability that everything is the same is less than 5%, or the chances that everything is the same due to the observations or recordings, whatever the case may be, is less than 5%. And if that is the case, then you obviously have to reject the null hypothesis in favor of the alternative, because the chances that this is actually true is less than 5%, meaning that there's a 95% or more chance that everything is different. Therefore you have to accept the fact that everything's different, right? You've kind of just proven that it's not the same. In some cases we may want that to be the case. In some cases we may not want that to be the case. So for example, if we're looking at these Vo2 max values in our cases, hopefully the Vo2 max values for the different tests are at least similar, right? They're not significantly different. So in that case, we're hoping that the null hypothesis is true and that the p-values are going to be bigger than 0.05. In other cases, we may want to have a significant difference. Say, for example, if we were testing two groups and we did an intervention, and hopefully the intervention that we did worked really, really well, saying that once we've finished our intervention, at the end of it all, we're hoping that not everything's the same, that there is a statistically significant difference. Okay, so hopefully that's just the theoretical background. What we'll do now is we'll open our template where we've got all our captured data. First thing that you guys need to do is make sure that you've deleted the Sagandera's data. So you'd basically just right click and click delete. I've already done that here. Part of what we want to do is now compare the Vo2 max values, right? You'll see I would have added an extra column here whereby I've converted the Vo2 max values, the absolute Vo2 max values in liters per minute, into relative Vo2 max values. Remember how to do that is you say take the absolute value multiplied by 1,000 divided by that person's weight. Okay, then you can just press enter and drag down, and you will have the relative Vo2 max values for each individual. That's for a little bit later. For now, part of what we want to do is assess the Vo2 max values for the Vo2 max treadmill test, the 3MT, the two modified 3MTs. I'm just going to show you all of them. You guys can adjust it accordingly, right? So I will highlight the entire column with the label, press Control, just go over, press Control, highlight the 3MT Vo2 max values and drag down. Then press Control again, highlight the 25 meter 3MT values, and then press Control again and highlight the 50 meter Vo2 max values. Then press Control C to copy it, open a new sheet, and then somewhere in the sheet you can just press Control V, and that will then paste the values in here. Okay, so now we can start our analysis where we start comparing these values. The first thing that we might want to do is run a correlation to see to what extent do the values within here correlate amongst each other. So to do that, you would need this data analysis tool pack up here, which you would find under the data ribbon in the ribbon above. If you don't have that, no problem. You click File, go to Options, go to Add-ins, then click the data analysis tool pack. At the bottom you'll click Manage Excel add-ins, click Go. This will pop up, and then just make sure you click the data analysis tool pack and hit OK. I've already done that, so I'm going to just click cancel. It will then appear up here in your ribbon. Okay. What you'll then want to do is press it. You want to click the correlation option, and then we're just going to highlight all of these values, including the labels. Press enter. It's grouped by columns because we are comparing 4 different Vo2 max values, and they are arranged in columns. Make sure that this labels in first row is selected because we did include that in our analysis. And then you can click where you want to output the information. So in this case, just click up here, select any cell, and then it'll start pasting the information there. Press enter and then click OK. What I normally do is just create some little space. I highlight all of them and then just double click the options, and it will run a multiple correlation analysis. Don't worry about the ones. That's just correlating Vo2 max in liters per minute to Vo2 max in liters per minute, 3MT Vo2 max versus 3MT Vo2 max. If you correlate those values, it'll be a perfect correlation, obviously. But what we're interested in is if we compare, say for example, the Vo2 max of the treadmill to the 3MT Vo2 max, you can see there that that's quite a strong correlation. Anything greater than 0.8 is a very strong correlation, and you can see all of these values are greater than 0.8. So that's kind of cool. We're kind of happy to see that there's a strong correlation between all of these values. What we want to try and see then is, obviously there's going to be a difference. They're not a perfect correlation, and we want to see if the variation is due to actual differences in the test or if it's due to randomness. And then we want to try and see if that's statistically significant. Alright, so the first thing that you'll need to do is run an F-test, because that checks for variation. So you go to your data analysis toolpack, go to F-test to sample for variance. We can basically compare just 2 columns at a time. So the first thing that you'll want to do is highlight the first column, or whichever column that you want to assess and analyze, and then select a second one. So in this case, I'm comparing treadmill Vo2 max to the 3MT Vo2 max values. Press enter. Again, I've highlighted the labels. Our significance level is set at 0.05. That's standard. And then the output range, I'm just going to select down here, press enter and hit OK, and it will then spit out some values. It'll give you the means and the variance, and then remember that our null hypothesis states that the variation between these two groups is going to be the same. So the p-value over here is 0.31, which is greater than 0.05. In other words, the probability that the variance of these two groups is the same is about 32%. Right? It's a whole lot bigger than 5%, meaning that the null hypothesis is true. We can't reject that. So the variance here is the same. That's good. what that now means is we're trying to see if they are statistically significantly different from each other. So to do that, we run a t-test. You'll see different options for t-tests. One of the reasons that we checked for the variance is because the one t-test is assuming equal variance, another test is assuming unequal variance. We've just proved that it is equal variance, so therefore we run the t-test with equal variance. Press OK. Now we're going to compare the two tests that we want to assess and analyze for significant differences. Again, I will just highlight the first one and the second one because these are the ones that I'm comparing to each other. Click labels. The alpha value is the same, and now I'm just going to kind of tell the computer where to start putting the values. Chuck it down there, press OK. In this case, I don't know if you guys remember like what a t distribution looks like, but part of what we're interested in is a two-tail value, and we're looking at the p-value here again. Remember, the p-value says that what we're trying to see is this the probability that these two are the same, right? And the probability that that is true is 67%, which is quite high, right? So it's saying that these two variables are not statistically significantly different from each other, right? So the fact is that they are very much similar, which is a good thing. So it means whether I assess your Vo2 max in the treadmill or I assess your Vo2 max in the field, there's not a statistically significant difference between these two tests, which is great. That's something that we want to see. So we definitely want to make a note of that. And I'll show you guys in the next video how we start graphing this and making notes on whether there's a significant difference between the two or not. So stay tuned for that in the next video. You guys will keep going. So whether you're comparing the 3MT versus the modified 3MTs, the principle is the same, right? So make sure you run your correlation, run the F test to check for variance, and then you know which of the two t tests you should use, whether it's equal or unequal variances, right? It depends on what your finding of the F test was. So hopefully that's made sense, and I'll take you through a few more examples in the next video.